Well, so regarding motivation of this problem, in general, we got easy problems and difficult problems, and we call easy problems those for which we got a polynomial time procedure that solves them. For instance, even one problem before these ones. If you have to multiply two matrices, then in order to obtain the product, then what you would do is to program an algorithm in order to go over all the cells in this matrix, computing the value of each of these cells. To go over all these cells is two nested for loops. So this is its complexity is a quadratic function. But in order to compute each of these cells, you have to go over the corresponding row from the first matrix and the corresponding column of the second matrix with the same index. So these add another n to the multiplication, and the global complexity of the algorithm is n powered to 3. So this remains polynomial. So there exists a polynomial time algorithm that solves the matrix multiplication. In the same way, there are other algorithms that solves these problems. For instance, the shortest path in a graph, which is solved with this algorithm, well, it runs in polynomial time. The continuous knapsack problem, where you got a set of objects, each object has got a profit and a weight. And you have to put these objects into the knapsack, but you have to the sum of the weights of the objects should not be larger than the capacity of the knapsack. Then if you are allowed to split objects, I mean, for instance, this object, you can take a portion of this object, then there is actually an algorithm that provides you with the optimal solution, and it runs in polynomial time. The idea is to sort the objects according to this quantity, which is the profit of this object per unit of weight. So if you introduce first the most interesting objects and leave the not that interesting objects for later stages, and you split the last object to fill the knapsack, then you get the optimal solution. But if you are not allowed to split objects, then you move to a non-polynomially solvable problem, or this is another problem for which there is not a polynomial time algorithm that provides you with the optimal solution. In the same way, there are other problems such as the traveling salesman problem. In the traveling salesman problem, the idea is that you got a set of customers, clients, or cities, and you have to visit all of them with a circuit, such as, for instance, this one. Well, perhaps this is not the best circuit in this graph. Then the idea is that you would like to find the best circuit. This is the traveling salesman problem. There are other problems, the maximum diversity problem, real parameter optimization. For instance, perhaps you are interested in designing a controller for an agent. This agent could be Super Mario Bros. Or could be a rocket which has to land on a platform, or perhaps it is a plane which has to fly from one airport to another airport. Obviously, it should not crash other planes and so on. Well, here you got a video of one controller of Super Mario Bros., which is quite interesting, which is actually produced by a genetic algorithm, which is a metaheuristic. Well, so just let me tell you that these kind of problems cannot be solved by brute force. With brute force, I mean evaluating all the possible solutions. For instance, if you try to evaluate all the knapsack solutions, then you got n objects. For instance, with this encoding, kind of coding, you could say that these objects are not put into the knapsack, but these ones are really put into the knapsack. Those for which this solution has got a 1. So, what is the possible number of different solutions for these problems? Is 2 to n. Well, so if you're able to evaluate one solution every second, and supposing that you got a problem with 100 objects, then the number of possibilities is 2 powered to 100, which is similar to 10 to power to 30. If you divide it by one solution per second, you will last this number of seconds. If you divide this by 3,600, then you will have something like 10 power to 27 hours. And if you divide it by 24 hours, then you will have something like 10 to 26 days. And if you divide it by 365, then you will have something like 10 to 24. Being optimistic, 10 to 24 years. So there is no time to evaluate all the possible solutions. And if you had the traveling salesman problem, the case is similar. Because in the traveling salesman problem, the number of solutions, which are permutations of the clients, is n factorial, which also grows exponentially. And if you got the problem of designing a controller for Super Mario Bros. Or another robot, agent, or system, whatever, then you will need to evaluate all the possible programs you could write for this system. So the number of possible programs is also very high. Well, there are many other difficult problems, NP problems. Here you got some names. And this is just a nice example of the traveling salesman problem with 3,100 customers. Obtaining the optimal solution in this case is quite difficult because, the number of potential solution is 3,100 factorial. which is not uh, well, I don't know. I think nobody can imagine such high number. Well,